Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kamal bin Anwar and I am from Group 17. Today, I and another group members want to present about our engineering drawing project DAK 10502. Before that, let me introduce my group members. First, we have Azuma, Akmal, and Fitri. Before we go to more deeply in our presentation, let me open with the introduction. Crude palm oil is one of the most widely produced and consumed vegetable oil in the world, derived from the fruit of the oil palm tree. Crude palm oil is a crucial component in the global food and non-food industry. The oil palm tree, native to West Africa, thrives in tropical climates and has been cultivated extensively in South Asia, particularly in Malaysia and Indonesia, which together account for approximately 85% of the palm oil production. Palm oil is an edible vegetable oil derived from the mesocarp of the fruit of the oil palm. It is naturally reddish in color because of the high beta carotene content. Palm mesocarp oil is 49% saturated, while palm kernel oil is 81% saturated fats. However, crude red palm oil that has been refined, naturalized, bleached and deodorized, a common commodity called RBD, refined, bleached, and deodorized palm oil, does not contain carotenoid. The palm oil is used in food manufacturing, in beauty products, and as biofuel. The main product of the palm fruit line are palm kernel and crude palm oil. For palm kernel processing, after pressing and separating, they also go through processes such as kernel or fiber separation, kernel conditioning, kernel crushing, kernel separation, and palm kernel drying. The dry palm kernel are sold to palm kernel mill to extract palm kernel oil. For crude palm oil processing, it generally requires complete processes such as sterilization, threshing, cooking, pressing, washing, purification, and drying. This is our PFD for the production crude palm oil. First, we have palm bunches, and then put into the sterilization, threshing, ligation, pressing, clarification, centrifugation, and drying, and last is storage. Fresh fruit bunch. Palm oil is extracted from fresh fruit bunches by a mechanical process whereby a mill commonly handles 60 to 100 meters per hour of FFB. The palm oil mill of today is based predominantly on concept developed in early 1950s. An average size FFB weight about 20 until 30 kg and contain 1,500 until 2,000 fruits. The FFBs are harvested according to harvesting cycle and delivered to the mill on the same day. The quality of crude palm oil is dependent on the care taken after harvesting, particularly, and on the handling of the FFBs. Fresh bunches FFB are the primary raw material used in crude palm oil production. FFBs contain fruits, kernel, and fibers. The oil palm tree originates from West Africa and was developed into an agricultural crops in Malaysia. The FFB are processed by a mechanical process whereby a mile commonly handles 60 to 100 meter per hour of FFB. The composition of crude palm oil can vary depending on the quality of the bunches arriving at the mile, the variety and age of the tree, agronomic and environmental condition, handling and transportation condition, and harvesting techniques used.
The second process is bunch sterilization. The sterilization of fresh fruit bunches is a crucial step in the production of crude palm oil. This process involves the use of large autoclaves where the fresh fruit bunches are steamed with high pressure steam at temperatures typically around 140 degrees Celsius to 145 degrees Celsius for 90 to 120 minutes. The purpose of sterilization is to halt enzyme activity that can degrade the oil, kill microorganisms, and soften the fruit to facilitate the separation of the fruit from the bunch. This process also reduces the free fatty acid content in the extracted oil, enhancing the overall quality of the CPO. After sterilization, the steamed fresh fruit bunches are transferred to a thresher machine to separate the palm fruits from the bunches before moving on to subsequent processing steps. Alright, so let's look at the third process, bunch threshing. What is bunch threshing? The bunch threshing process in the production of crude palm oil is a crucial step that follows sterilization. In this stage, the sterilized fresh fruits bunches are fed into the thresher machine designed to separate the palm fruits from their bunches. The thresher uses rotating blades or a drum to mechanically loosen and detach the fruits from the bunches. The separated palm fruits fall through openings at the bottom of the thresher, while the empty bunches are discharged from the machine to be used as fuel or compost. This threshing process ensures that only the palm fruits proceed to the next processing stages such as digestion and pressing, thereby enhancing the efficiency and quality of the oil extraction. Alright, so next let's look at the fourth process, bunch digestion. The digestion process in the production of crude palm oil involves breaking down the separated palm fruits to facilitate oil extraction. After threshing, the fruits are fed into a digester machine which consists of a cylindrical vessel equipped with rotating blades. The fruits are subjected to mechanical agitation and heat, typically maintained at around 90 degrees Celsius to 100 degrees Celsius. This process ruptures the oil-bearing cells in the fruits, mesocrab, and converts the pulp into a uniform mesh, making it easier to extract the oil. The combined action of heat and mechanical stirring helps to release the crude palm oil from the fruit pulp, preparing it for the subsequent pressing stage where the oil is physically separated from the fibrous material. Next, let's move to the fifth process, bunch pressing. The pressing process in the production of crude palm oil involves extracting the oil from the digested fruit mash. After digestion, the fruit mash is transferred to a screw press or hydraulic press. In the screw press, the mash is subjected to high pressure as it moves through a perforated barrel by a rotating screw. This pressure forces the oil to separate from the fibrous material and flow out through the perforation. The extracted oil, now a mixture of oil, water and solid, is collected and sent for clarification. The remaining fibrous cake, which still contains some oil, is expelled from the end of the press and can be further processed or used as a byproduct. This pressing process is critical for maximizing oil recovery and ensuring that the crude palm oil extracted is of high quality before further refining and purification steps.
Next step is bunch clarification. The clarification process in the production of crude palm oil involves separating the oil from water, solid impurities, and other contaminants. After pressing, the extracted oil, which is a mixture of oil, water, and solids, is pumped into a clarification tank or settling tank. In the tank, the mixture is allowed to settle, enabling the heavier solid and water to sink to the bottom while the lighter oil rises to the top. to the top. The clear oil is the skim off and may undergo further purification through centrifugation, which uses centrifugal force to remove any remaining impurities. This step ensures that the crude palm oil meets quality standard and is ready for storage, further refining, or direct use. The separated water and solids, often referred to as sludge, are either processed to recover residual oil or used as feedstock for biogas production or as organic fertilizer.
The next one is bunch centrifugation. The centrifugation process in the production of crude palm oil (CPO) is a crucial step for separating oil from water and solid impurities. After the clarification stage, the crude palm oil mixture, which contains oil, water, fine solid, is fed into centrifuge. Centrifuge operates at high speed, generating centrifugal force to separate the components based on their densities. The lighter oil is pushed toward the center and collected from the top, while the heavier water and solid impurities move toward the outer edge and are removed through separate outlets. This process ensures that the oil is further purified, releasing its moisture content and removing fine particulate matter, thus enhancing the overall quality of the crude palm oil. The separated water and solid, often referred to as sludge, can be processed further to recover residual oil or used in other applications such as biogas production or as organic fertilizer. The refined oil from the centrifuge is then ready for storage or additional refining process. Then, crude palm oil drying. The drying process in the production of crude palm oil (CPO) is essential for releasing the moisture content to ensure oil stability and prevent spoilage. After centrifugation, where most of the water and impurities are removed, the crude palm oil still contains some residual moisture. The oil is then passed to a vacuum dryer or heated drying system where it is subjected to low pressure and controlled heat. This environment causes the remaining water to evaporate without overheating or degrading the oil. By reducing the moisture content to an optimal level, typically below 0.1%, the drying process helps in improving the shelf life and quality of the CPO. The dry purified oil is then ready for storage, further refining, or direct use in various applications. The last one is crude palm oil storage. After processing, crude palm oil undergoes storage to wait further refining or distribution. Typically, CPO is stored in large tanks with heating and agitation system to maintain optimal temperature and prevent solidification. These tanks are designed to ensure that the oil remains homogeneous and free from contaminants. Periodic sampling and testing are conducted to monitor quality parameters such as moisture content, acidity, and impurities. Proper storage conditions help preserve the quality and stability of the CPO until it is ready for downstream processing and post-shipment to end user. Additionally, storage facilities are often equipped with safety measures to prevent contamination and ensure compliance with food safety standards, enhancing the overall integrity of the product. In conclusion, crude palm oil is a highly versatile product in high demand for various applications, including food, detergent, cosmetic, and biofuel. However, its production poses significant challenges such as deforestation, loss of biodiversity, and social issues. To address these strategies, like sustainable production practice, certified sustainable palm oil, efficient extraction method, waste management, reducing deforestation, and promoting forestation can be employed. The industry can also improve energy efficiency at palm oil mill, implement integrated biorefineries for biomass processing, and adopt energy efficient technology to produce crude palm oil more sustainably and responsibly. By implementing these strategies, the palm oil industry can meet global demand while minimizing environmental impact and supporting local economies and employment in tropical countries.